Hello guys, I am Parinita and welcome back to my channel to polish your CSE concepts with me. So let's get started. In this video we are going to see about the LR parsers. In my previous video, if you have seen that, we have already discussed about the LR parsers. We have seen which are the main four types of LR parsers and the main points regarding LR parsers. What is L, what is R, why LR parsers are required, fine. Now from this video we are going to actually learn how the LR parsers work and what is the procedure. So first of all we are taking LR0 parsers. In this video we are going to see how we can construct the table of LR0 parsing table, how we can construct the LR0 parsing table. We will see how to parse any grammar. If any grammar is given, then how, with the help of the whole procedure, how at the end we can say that whether that grammar is LR0 or not. That is actually the main type of question that has been asked. You will be given one grammar and they want you to solve the whole procedure, or however they want you to tell that whether the given grammar is LR0 or not. So that is the main task that we have to do. Okay, then let's see with the help of example. Here one question is given, one grammar is given. As you can see, S gives AA and A gives small a or B. This is the grammar given and the question is again the same, that state that whether this grammar is LR0 or not. So how we can do that? See, you will be having some new terms. I will explain you as and when we proceed. Whenever for finding that whether a grammar is LR0 parser or not, the first thing we have to do is make a canonical collection of LR0 items. Now obviously you must not be knowing that what is canonical collection, so I will be explaining. What is canonical collection of LR0? See, these are the productions. How many productions here are there? S gives AA, A gives small a and A gives B. Total 3 productions are there. So what I have to do is, I will write it in the form of LR0 item. That means, see, let's start from here. I'll write S is giving what? AA, but we will write it as S gives dot AA. Similarly, A gives dot small a and let me write it together, dot B. Now why we are writing it like this? S gives dot AA. Whenever I am writing, see, this notation is known as LR0 item. Whenever we are having dot in the beginning, it is known as LR0. It is known as LR0 items. Now what is the meaning of writing it like this? Dot, whenever we are writing dot in the RHS of the production, that means what? Whatever is there after that dot, all these are yet to be seen. Fine, S gives dot A means we are just starting the production and we have not seen anything. You will see that as we will proceed here, slowly what will happen, my dot will start coming to the right. That means what? If I have visited this capital A, first capital A, then I will get A dot A. Once my whole string is visited, I will write S gives AA dot. So when I am having dot in the beginning, that means I have not started anything, and whenever I have dot in the end, you can say that my whole production has been parsed. So this is how we will start, that we will start with dot in the beginning for all the productions. We will go on parsing one by one. I will show the whole procedure, and at the end, when you are getting dot at the end, you can say that it is a reduced production. That means the production we have already visited the whole. Fine, so this is how we will proceed. So first of all, I will get dot in the beginning, that is S gives dot AA, A gives dot AA or dot B. Now one more thing here, starting symbol is there, so it is important to pass this starting symbol also. So what we are doing for that, see, these 2 productions are that which are already given, but for the starting symbol what I will do is, we will be adding one augmented production, that is S dash gives S. S dash gives S. This is known as augmented production, and this augmented production we have to add by ourselves. Now again S starting symbol, it is also yet to be visited because we are just starting. So here also I have to put one dot. So S dash gives dot S. Now this I got, this is known as one state. In this case we will work step by step. This is known as first state. I will name it as I0. Fine. Now we will keep proceeding by visiting one element at a time. How? So here it is. See, here in the very first production, what is there after dot? Just after dot we are having capital S. That means we will parse S first. So capital S. Now when I am saying that I am parsing S, that means S from when I will reach the next state, this S would have been parsed. So instead of S dash gives dot S, my dot will be now after S. So I will get S dash gives S dot. Fine, because here I am already parsing S. So dot will be after S now. So I will get S dash gives dot S. Then in the second production, after dot, immediately after dot we are having capital A. So I will parse it capital A. So I will get what? This dot will come after capital A, after one capital A. So I will get A dot A. So S gives A dot A. Now one more rule is there. Whenever we are having after dot, if I am having any variable, again after dot, if I am having any variable, after dot, right, after dot, if I am having any variable or any non-terminal, after this production I have to write that variables productions also. So here after dot we are having one variable A, so I will be writing the productions of A also. So the productions of A were AA and B. So dot AA and dot B. Fine. Now here after dot variable is there? No. Here after dot variable is there? No. Both are terminals. So I don't need to proceed it further. This will become my second state. Okay. So I have done with this production also. In the third production we are having A gives dot AA. So again dot A small a. I have to parse small a. So I will parse small a and I will get what? A gives dot will be after small a. So A gives A dot A. Now again dot after dot we are having one variable. So I have to write its production also. So I will get this. Fine. Again after dot we are having on terminal. So I don't need to proceed. This will be my state. Then we are having last production, that is A gives dot B. So I have to parse B. After parsing B, my dot will come after B, so I will get A gives B dot. Now here dot is in the beginning, as I told. Here see, dot is in the beginning, so I can say that this B, A gives B, this whole production has been parsed and this is known as my reduced state. Fine, reduced state means the state in which my whole parsing ends. So this state is known as reduced state. So what do we mean by, so what is the use of reduced state? At the time of filling the table, the reduced states will be filled in a different way. I will show you that. Fine. So yes, for this production we have completed the whole parsing. Now we have to proceed. It is kind of tree. We have to keep on proceeding unless all the productions are completed. So here see, here you can see that A gives B. This one production is completed, but remaining two productions are yet to be completed. So we have to proceed here. Now S gives dot, S dash gives S dot. Here dot is already in the end. We need not to proceed. If I see about this, S gives A dot A. So again after dot, here capital A is there. So I have to parse this capital A again. So parsing this capital A, I will get what? S gives dot will come after this A. So A dot. Fine. As you may see, S gives A dot. Again dot is at the end. This is a reduced production. Reduced production of this, which one? This S gives AA. This production has also been completed. Fine. Okay, I don't need to go further. Now S gives dot AA or dot B. It will give me what? Again I will parse this small a. So see, if I parse again this small a, I will get what? A gives small a dot capital A. Fine. I will, after parsing this much, I will get A gives small a dot capital A. This is the same one. A gives small a dot capital A, and for capital A again I have to write A gives dot A or dot B. So I can write again one more state, but if this state is already available, we will just do the transaction from this state to that state. That means what? If I parse small a in this state, I will get the same state. So we don't need to write this state again. We can just do the arrow and show that from small a, if we parse small a in this state, I will be reaching this state only. Fine. Okay, then A gives dot B. So if I parse small b here, I will get A gives B dot, and it is also available. So I will just do my arrow and show that this is my same states for small b. Fine. So all the states of from this state have been covered. Now we have to cover this one. A gives A dot A. So if I parse here after dot, we are having capital A. So I have to make one transaction for capital A. I will get what? A gives A dot. Dot will come one after. So A gives A dot. Again, this is my final state of this third one. A gives A. That is, this is a reduced state. Fine. So this is done. And for this one, if I am doing, then A gives A dot. So for small a, I will be reaching in this state itself. It is a recursive function. For small a, I will be reaching here only. And for small b, A gives B dot. So for small b, we will be again going to this. I will be again going to this state. Fine. So this is how the all the states will be. Yes. All the states are completed. See, here dot is at the end, here dot is at the end. We have done all the transactions for this. We have done all the transactions for this. For these two, again dot is already at the end. So I need not to move further. This is my whole states. We have covered all the states. Now let us quickly name the states. See, here we have already named it as I0. Let me name it as I1. This one is I2. This one is I3, this one is I4, I5, I6. These are my states. I have already named them. Now why we have named them? Because what my main task is to say that whether this grammar is LR0 or not. In order to say that, what we have to do, we have already made this canonical collection of LR0 items. This whole tree-like structure that we have made, this whole tree-like structure is known as canonical collection of LR0 items. Fine. So we have made a canonical collection of LR0 items. Now my main task is to make LR0 parsing table and check that whether this grammar is LR0 or not. Now how to make LR0 parsing table? We are having, see, let's start making LR0 parsing table. Let me make it here. We are making LR0 parsing table. For LR0 parsing table, we are having something known as action part and we are having something known as go to part. In action part, always our terminals will be there. So in my grammar, which are the terminals present? A and B. So A and B will be there, and with A and B always we will be having dollar. So in terminal part, all the terminals that are present in the grammar will be there. Apart from that, one dollar will also be there. That will be my action part. And in the go to part, the remaining, that is the variables will be there. Whatever variables or non-terminals are there in grammar, they will be in go to part. So in my case, I am having capital A and capital S. Capital A and capital S. These are my two variables or non-terminals. And what will be there? What will be here in the row part? In the rows, all my state numbers will be there. How many states I am having? 0 to 6. So here I will write 0 to 6. 0, 1, 2, 3, 4. I am just making the line for our clear understanding. 5, 6. So I have written 0 to 6. Fine. So remember this structure. We will be having action part, go to part, and all here I am writing all the state numbers, the numbers that I have got. Okay, now again the main task is to fill this LR0 table, LR0 parsing table. How to fill it? 0. Whenever we are at the 0th row, we will see the 0th state. Now, how to see this? From 0, we will see all the transactions that we are doing from that state. So, how to write it? From the 0th state on capital S, I am going to 1. From 0 on capital S, I am going to 1. From 0 on capital S, I am going to 1. So, I am writing here 1. Got it? It is simple. From 0 on capital S, I have gone to 1. One more thing, whenever we are writing in the go to part, we will just write the state numbers 1, 2, 3, whatever it is there. But in the action part, we will write it as S1, S2, S3 like that. Why? Because whenever in the action part, that means whenever from one state on any terminal, we are going to another state, it is known as shift move. So, we have to append S with it. Fine. Okay, we have already done one entry here. Now second, on 0, from the state 0 on capital A, I am going to 2. From 0 on capital A, 2. From 0 on capital A, 2. From 0 on small a, 3. From 0 on small a, 3. But here it is action part, shift move. So, I will write S3. From 0 on small b, from 0 on small b, we are reaching 4. From 0 on small b, we are reaching 4. Fine. This is how we will fill the table. Fine. Then from 1. 1 is actually augmented C. 1 means whenever we are in the first row, we will see the first I1 state. Here in the I1 state, this is actually an augmented production. Augmented means we have added it. S dash gives S dot. We have added it. It was not given in our original table, and this is the ending state or the accepting state for this. So what we will write whenever we are having the acceptance state of augmented production that we have added, we will simply write in the dollar. We will simply write accept. Fine, you have to remember this. This is a special case because this is the augmented production that we have added. Fine. Then in 2. So, from 2 on capital A, I am going to 5. From 2 on small a, I am going to 3. From 2 on small b, I am going to 4. Now 3. From 3 on small a, I am at itself. From 3 on small a, I am in 3 only. Okay. From b, I am on 4 only. From 3 on capital A, I am going to 6. 4. Now I4 state, this is A gives B dot, means as I have explained you there at that time also, this is a reduction state. For this, A gives B. This is a reduction. Now, for reduction, what we are doing, we will write this entry as R because it is a reduction. So, R in the whole action part. Now, R what? We have to name it as, let's name the production. For example, S gives AA, let's name it 1. A gives AA, let's name it 2. And A gives B, let's name it 3. We are just naming the productions. Now A gives B dot. So A gives B is the, what is the number of A gives B? 3. So this is a reduction state. So in the end, in which state? I4. So in the row number 4, for reduction I will be writing R, and which is this number of production? A gives B, this is third number. So I have to write R3 in the whole action part. In the whole action part, I have to write R3. Fine. Now 5. From 5, it is also a reduction move. S gives A, that is first one. So I have to write R1 here in the whole action part. And 6th, this is also a reduction part of the second production. So I have to write R2 in the whole action part. Fine. So this is how we have made the table, and again here the rule remains same as LL1, that after filling the whole table, if all the entries, all the entries means if all the cells are containing only one entry, there is no duplication, simply I can say that yes, my grammar is LR0. If there is any duplication in any cell, means in any cell if you are getting more than one value, you can straight away say that this is not LR0. Fine, I hope you have understood the whole procedure. It is easy, you just need to practice more.